Hello there, Mr. Sutton here, bringing you the IM3 Chapter 5 Quiz 1 review solutions on solving polynomials and synthetic division. To solve this polynomial equation, we first look to see if we can take out any common factors, and it looks like we can. These all have an x, so we're going to factor an x out of all this. And if I do that, I'm left with parentheses with a x squared plus x minus 20. All of that equaling 0. And now I can try to factor the stuff that's inside there. So I need factors of negative 20 that add up to that middle coefficient. There's an invisible 1 there. So we have 1 and 20. That's not going to work. Neither does 2 and 10. 4 and 5 could work if I had negative 4 and positive 5. So I'll split that up. I'll have x minus 4 and x plus 5. And now setting each of my three factors equal to 0 and solving, I see for this first factor that x equals 0, and then 4 will zero out that second factor, and then negative 5 the last factor. To solve this polynomial equation, let's first look to see if we can take out common factors. Doesn't look like we can, so we move on to other things. Now, one other thing we check for is to see if it's in quadratic form. We see that we've got fourth power, second power, and a constant. That is quadratic form, where your first exponent is twice the second one, and then you have a constant as the last thing. So we can basically factor this just like a quadratic, only instead of x, we're going to use x squared when we split things up. So I need factors of negative 42 that add up to 1. There's an invisible 1 next to the x squared for that middle coefficient. So we've got 1 and 42, that won't work. 2 and 21 doesn't work. 3 and 14 is no good. Let's see, 6 and 7 would work if I had negative 6 and positive 7. So I'll split this up into x squared minus 6 and x squared plus 7. And now I'm just going to set each of these equal to 0 and solve them individually. So if x squared minus 6 equals 0, then we can say that x squared equals 6. And then square rooting both sides, don't forget the plus or minus, we have x equals plus or minus radical 6. And we can't simplify that anymore. Now for this other one, I can say x squared must equal negative 7 if I subtract 7 there. And then square rooting both sides of that, well, if I'm taking the square root of a negative, I'm popping out an I. So I've got plus or minus I radical 7. For this problem, trying to solve this polynomial, let's first see if we can take out any common factors. Looking at all these four terms, it doesn't look like there are any common factors. But maybe we can factor by grouping since we've got four terms. So let's try that. We'll take an x squared out of those first two terms, and that leaves us with 3x plus 7. For the next two terms, we can take a negative 8 out of both of those, and that leaves us with, let's see, a 3x, positive 3x, and a positive 7 there as well. And now it looks like we have a 3x plus 7 that we can take out of everything, leaving us with x squared minus 8 in the other parentheses. And now let's set each of these equal to 0 and solve. If 3x plus 7 equals 0, well, I could subtract 7 and divide by 3 to get negative 7/3. So that would be one answer. And then for this other one, I can add 8 to the other side. And now I have to square root both sides to solve this. Now when I do that, I'll have a plus or minus. And if I have the square root of 8, I can simplify that. I can split that up into radical 4 times radical 2. So we've got plus or minus radical 4 times radical 2. But we can square root 4, so that's actually plus or minus 2 radical 2. For this problem, to find the remainder by doing this division, and also whether our divisor is a factor of the dividend and the quotient, synthetic division does all of that for us. So to start the process, we write down the coefficients of the dividend, the thing that's being divided. So we have a 1 for the 1x cubed, a 2 for the 2x squared, and then we have a 12 and a 24. And you should always check to make sure there's no missing terms, but there aren't. We go third power, second power, first power, 0 power. Now we're going to write down a little box with the opposite of whatever we have in this parentheses, whatever zeroes out the divisor basically. So that would be negative 1 in this case, because negative 1 plus 1 is 0. And we're going to leave some space for another row and then draw a line. And in this middle row, whatever's in these top two rows here, we're going to add together and put down below. Now, whatever is down below, we're going to multiply by this -1 and put it in the second row. So let's bring down this 1 to start with. It's kind of like adding 1 with 0. And then -1 times 1 gives me another -1 up here in the second row. 2 plus -1 gives me 1 down here. Times -1 gives me -1 again up here. Now I have 12 plus -1, which is 11. And -1 times 11 is -11. 24 plus -11 is 13. This last number right down here in the bottom row, that's your remainder. So we say remainder 13. And if the remainder is 0, then the divisor is a factor of the dividend. If the remainder is not 0, like in this case, then the divisor is not a factor of the dividend. And to write the quotient, we use all the other numbers that are not the remainder, so 1, 1, and 11, and those are the coefficients of the quotient. Now, in terms of the exponents, we always go one exponent lower than we started. And here, you basically divided an x cubed by an x. So you should end up with something that starts with an x squared. So this 1 right here represents 1 x squared in your quotient. And then this 1 is really a plus 1x. And then this 11 is really just plus 11, the constant. To find the remainder from this division and all the other information they want, we will use synthetic division. So let's start by writing the coefficients of our dividend. So we have a 1 for the 1x cubed. And you'll notice we're missing an x squared here. There's really an invisible 0x squared. So when you have those missing terms, you have to have a 0 for a placeholder. Next, we have -18 for the -18x, followed by -8 for the constant. And now for my box number, that's going to be whatever zeroes out my divisor, -4 in this case. Let me leave some space, draw a line, bring down that first coefficient, and now -4 times 1, that's going to be -4 up here in the second row. 0 plus -4 is still -4. -4 times -4 is 16. -18 plus 16 is -2. -4 times -2, +8. And then -8 plus 8 gives us 0. Since our remainder, this last number down here, since that remainder is 0, that means that our divisor, x plus 4, is a factor, so yes is a factor of our dividend. And then our quotient is these other numbers down here that aren't the remainder. So this 1 really represents 1x squared. It's always 1 lower than the exponent we started with. So that's 1x squared minus 4x. And then this -2 is just the constant -2.